So this is my private land. In this private land, I'm going to build my own city. I mean, my private city. So for this private land, I do have one main gate here. So anyone can outside enter into my private land only via this main gate, right? And even both entry and exit will happen via this main gate only. People who are coming outside, they are accessible to public amenities like restaurants, malls, and hotels, right? This is my public area. In the other hand, even I have built private areas like bank vaults, government data centers. So actually for these amenities, publics are not allowed to enter directly, right? So to enter public from main gate to my public area. For this, we need to build roads, right? Let's assume I have built roads for this thing as well to enter from main gate to public area. At public area, we do have one checkpoint. In this checkpoint, checks will happen both during entering inside public area as well as while exiting from the public area as well. So this is my checkpoint. Inside this public area, we do have multiple uh, buildings, right? One is restaurants, malls, hotels, and all. Even in front of all these things, like in front of hotels, malls, restaurants as well, we do have one more security guard called security guard. So while entering public inside this public area at checkpoint, both checks will happen during both enter and exit. Whereas at in front of hotels, malls, and all, checks will happen only during entering inside the hotels, malls, and all. So here I'll draw one more diagram. So this is my public area. So while entering inside this public area, we do have one checkpoint. Here, during entry and exit, during both the cases, checks will happen. Checks will happen. Whereas inside this public area, we do have multiple buildings, right? Hotels, malls, and all. So here as well, we do have security guard. Here, during in only checks will happen. Only during entering inside the hotel or malls, security checks will be happen. Right? Then coming to the private area. While entering inside private area, here as well we do have one checkpoint. So during enter and exit, during both the cases checks will happen. And inside this private area, we do have multiple buildings called government data center, bank vaults, and all. While entering inside these buildings, checks will happen, but not while exiting. Yeah, that's the one thing. And yeah, so and one more thing, while entering from main gate to public area, we have built roads, right? In the same way, few people who has authorized are able to enter into the private area as well, right? For them as well, roads will be built from public area to private area. So in the same way, this is one simple story to understand the VPC in a better way. Now I will explain the actual VPC in the AWS. Let's assume first thing I'll explain what exactly the AWS VPC is. Just give me a minute, guys. Yeah, AWS VPC. First thing, VPC is stands for Virtual Private Cloud. It's a logically isolated virtual network that is created within a AWS. Meaning, let's assume this is my AWS. Within that, I have created one logical isolation network called VPC, right? So using this, we are going to control the incoming and outgoing traffic to our applications. Yeah, this is my VPC. But to enter into inside VPC, we do have one main gate called Internet Gateway, IGW. All the traffic which is coming from internet. Let's assume this is my internet. All the traffic which is coming from the internet will enter into my VPC via Internet Gateway. Both entry and exit, both will happen via Internet Gateway. Yeah. Once traffic enter inside the VPC, here we do have public area called public subnet. So I'll also explain what exactly the public subnet. So let's assume here we have created VPC with a CIDR range of 10.0.0.16. So subnet is nothing but a small portion of VPC network. So let's assume right now if we have this CIDR range, our IP count will become. So I'll show you how to calculate the IP count. Always you need to follow this formula 2 power 36 minus here we have provided 16. It will be 2 power 32. So you will get 2 power 16. 2 power 16 is nothing but 65,000 something you'll get. So total IP count will be 65,536 something you'll get. So these are all the IP addresses right now available within our AWS VPC. So in that VPC, AWS will reserve total 5 IP addresses. So we left with 65,531 IP address. So in this IP, these IP addresses is going to divide into multiple parts. Like we are going to split up into multiple parts. Like one group is called, this is public subnet, right? For public subnet, we can assign 255 IP addresses, like for private IP address as well. So we can assign 255 IP addresses. Yeah. CIDR, before that, I'll explain subnet. Subnet is nothing but smaller network created within the VPC IP address range. Yeah. So this is the complete VPC address range. In that we are splitting this IP address into smaller portion. That is what exactly the public subnet. And here for the public subnet is nothing but it has direct access to the internet. Here we are using IGW, right? IGW is nothing but internet gateway. Public, whatever the resources we are going to create within the public subnet has the direct connection to the internet. Like if let's assume here we have created one EC2 server. So in case since it is directly created inside the public subnet and it has direct connection to the internet, it has two IP addresses. One is public IP and another one is private IP. So public IP will be used to communicate with the internet. In the other hand, let's assume here we have private subnet. In this subnet, we have created few EC2 servers. Yeah. Here, in case of private, what exactly the private subnet is nothing but the subnet which do not have direct internet access is known as private subnet. See, in case of public subnet, traffic will directly coming from internet gateway to this public subnet, right? That is not the case with respect to private subnet. There is no direct internet connection to this private subnet. So here in case, let's assume in the private subnet, we have created EC2 instances. Here we will get only private IP address. We do not have any public IP addresses in case of private subnet. So what we will achieve using private subnet is nothing but high security. We are not going to expose our server details to the internet, right? If we expose anything to the internet, there is always a threat to our applications or servers, whatever the things we are hosting, right? So to avoid the internet threat or security vulnerabilities, always in 99% cases, our applications will be deployed in private subnets. Right here, we do have a few EC2 servers, right? In the same way, we can create multiple private subnets, and in the subnet, I have DB servers. But still, these servers requires internet access, right? Let's assume to upgrade the patches. This OS patches and all, we require internet to download the OS patches, right? For that, what we will do, like in the public subnet, we will create one more component called NAT. NAT is nothing but network address translator. So again, as I mentioned here as well, from IGW to public subnet, we will create route table, right? In the same way, we will create one more route table from this private subnet to NAT. Whenever this server requires to access the internet, So request will flow through from this subnet, private subnet to NAT gateway. NAT gateway will mask the actual private IP address of this particular EC2 instance, and it will provide one dummy IP address, and then request will be flown into this via internet gateway to internet, right? What exactly NAT will do, like it will mask the actual private IP address of the instance, and it will provide some dummy IP address, and then traffic will be flown to the internet. Then we will get the response from the internet. Again, it will match this dummy IP address with the actual IP address which is stored in the NAT gateway. Based on that, request will be rerouted. Got it? Yeah. And I have mentioned about checkpoints as well, right? So at subnet level, we create, yeah, let's assume this is my private IR public subnet. Public subnet. So here we will define NACLs. NACL. NACL is nothing but network access control list. Here we are going to define both incoming traffic as well as outgoing traffic. Let's assume if you want to access any our application, see right now at here you can see, right, https Eduwise indoor mysharepoint.com, right? In the same way, this domain name will be translated into like this: https www.eduwise.com. Let's assume we are writing this URL. So behind the scenes, what happens, like it will redirect to host name. Host is nothing but, let's assume in our case, our IP address will be public IP address 192.172.102.100. This is our IP address, and our application is running on, let's assume, port number 3000. This is just for the just I'm trying to convey the things to you guys. No need to worry why exactly I'm using this public IP and this port only. This is only for the conveying the things to you guys. Yeah. Let's assume in this public subnet, we do have one EC2 instance. So this EC2 instance has two IPs. One is public IP and another one is private IP, right? Our public IP will be this thing: 192.172.102.100. And our private IP will be, let's assume, 10.101.112.100. So to access this server, we are going to use this port number as well, right? 3000. So in this NACL or NACLs, we need to define both incoming and outgoing, right? So here we need to allow port number 3000. This is incoming traffic as well. We need to allow port number 3000, as well as outgoing traffic as well. We need to allow port number 3000 at NACL level. Again, here for EC2, we do have one more security guard, right? Here at AWS, we will call it as security groups. Security groups will act as a virtual firewall to our EC2 instance. EC2 instance is nothing but virtual machine. For virtual machine, security group will be acted as a virtual firewall. Again, at security group as well, we need to define the incoming traffic. So meaning at security group level as well, we need to allow incoming traffic, port number 3000. So this is just a dummy port number. No need to worry why exactly I'm using this 3000 only. Yeah. So if we allow at security group, automatically it remembers that yes, I am letting in this port number 3000 to enter inside my EC2 server. So automatically it will allow for outbound as well. So here no need to define the explicitly that both incoming and outgoing port numbers at security group level, right? That's the one thing I want to convey you guys. And one more thing is route table. As I mentioned here, this is one route table from internet gateway to public subnet, and one more route table from private subnet to NAT gateway. So it will route the traffic from subnets to, like here in case of private subnet, it will route the traffic from private subnet to NAT gateway. Routing is nothing but redirecting, showing the path to flow the traffic. That's it. Now we will proceed with creating the actual VPC. As I mentioned, take this as an example only. We will create AWS VPC with this example only. We'll go to AWS console. One second. So for that, you need to search here for VPC. Once you search that VPC, you'll get this dashboard. Here you can see your VPCs, right? So then you can click on this create VPC button. Here we will get VPC only and VPC and more. What it means like, so as I mentioned earlier, first I have created VPC only. Inside that again, I have created public subnet, private subnet, internet gateway, NAT gateway, route tables, and DB subnet, everything, right? So if we choose VPC only, we need to explicitly create everything. So if we choose other option, VPC and more, in a single chat, we can create all the things. So for this session, I'll go with VPC only. Now I'll create a VPC called Eduwise VPC. Eduwise VPC, and here I need to provide the CIDR range. As I mentioned here, I'll provide only this range 10.0.0.0/16, right? So we are not going to use IPv6 here. We'll go with IPv4 only. So no need to choose any other option. I'll click on create VPC, right? So as of now, I have created one VPC. I have created this Eduwise VPC with CIDR range of 10.0.0.16. So that means you already know how to calculate the IP count, right? So 2 power 32 minus, here we are using 16. It will become 2 power 16. 2 power 16 is nothing but 65,536. Here AWS will reserve 5 IP addresses. So we will get 65,531 IPs. So what exactly this means, like AWS. So just I'm trying to convey you guys, AWS allowing us to create up to 65,531 AWS instances. Got it, right? Yeah. Now we have created this VPC. For this VPC, now we will create internet gateway. So again, yeah, at the left section panel dashboard, you can see that these options, right? So now I'll go to internet gateway. See, you can see internet gateway option here. And here click on create internet gateway. Here we need to provide the internet gateway name. I'll provide it as Eduwise IGW. IGW is nothing but internet gateway. Create internet gateway. Yes. Right now somewhere we have created this IGW. We need to attach it to VPC, right? In the next step, we will attach this internet gateway to our VPC. So for that, again, internet gateway, click on this one. Here you will get actions attached to VPC, right? So here we need to choose our VPC. In our VPC is Eduwise VPC. We'll choose it, attach internet gateway. Yes, we have attached internet gateway to our VPC, so that whatever the things we are going to create within the public subnet will able to access the internet directly. Right now we have created internet gateway and attached to VPC. In the next step, we will create two subnets. This is public subnet and one more thing called private subnet. So actually in real world, there is nothing called private and public. Those subnet which has internet access is called public subnet. Those subnet which do not have direct internet access called private subnets. So now we are going to create two subnets. So when we create the subnets, by default, both will be private subnets only because there is no direct internet connection. Later, we need to create the route table to change it into a public subnet. So now I will create two subnets. So for that, again, left side, left dashboard, you can see that subnets, right? Click on this subnets and here create subnet. Once you click on that create subnet, again, here we need to choose the VPC. Yes. And I'll name my subnet as public subnet, Eduwise public subnet only. Eduwise subnet. So by default, even this will be private subnet only. Once we edit that route table to route the traffic from internet gateway to this subnet, it will become public. Till that time, even though its name is public subnet, it is a private subnet only, meaning as of now, it doesn't have internet connection. So if you required any availability zone for this subnet, you can choose it. So as of now, I'll proceed with no preference, and our VPC CIDR block is this thing only. So here subnet is nothing but, as I mentioned earlier, it is a small portion of VPC. So right now we do have 65,000 IP address, right? In that I'll take X number of IP addresses and create one subnet. So yeah, that's what exactly I'm going to do now. Here we need to define our subnet IP CIDR block. So 10.0.1.0 slash we can give it as 24. So it will become 256. And how exactly why it is showing 256 means, so 2 power 32 minus, here we have given us 24, right? One second, guys. 24, right? So we need to subtract that 24. Then it will become 2 power 8. 2 power 8 is nothing but 256, right? That's how it's showing CIDR block range as 256 IP addresses, right? So either you can create right now by clicking this create subnet, or else you can add multiple subnets as well. So for that you need to click here. So now I'll add one more private subnet. So for that I'll click here, add new subnet. See here you are able to see, right? Subnet 2 of 2. So this will be our subnet 1, and this is our second subnet. So for this subnet I will name it as Eduwise private subnet. Again, if required, you can choose availability zone as well. Right now I'll proceed with no preference only. And again, here we need to provide the CIDR block for the new subnet, meaning, yes, within this 65K IP addresses, we already took 256 IP address, right? In the same way, again, we are going to take some number of, let's assume here we are going to take Y number of IP address and create subnet. So yeah, here I'll define as 10.0.2.0 plus 24. Here as well, you can see, right? We are taking 256 IP addresses for this particular subnet. So now if required, still you can add new subnets here. If you click on this thing, see 3 of 3. I don't want to add any subnet, so I'll click on this remove. And here I'll click on create subnet. Now we have created AWS VPC. Inside VPC, also we have created and attached internet gateway. Inside VPC, we have created two subnets, subnet 1 and subnet 2. That thing I'll show in here as well. So click on this your VPC. See, this is our AWS Eduwise VPC. Click on this VPC ID. Here you can see, right, resource map. Yeah, you can enable this show all details button. Our VPC name is Eduwise VPC. We have created two subnets, Eduwise public subnet and private subnet. And yeah, even we have created internet gateway, but still we have not routed anything to internet gateway, right? That's why here it's showing network connections is 0. So next thing, we will create NAT gateway. Do remember that NAT gateway always will be created inside the public subnet. And what exactly NAT gateway does, like whatever the traffic coming from the private subnet, it will flow through NAT gateway to the internet gateway. Here at NAT gateway, it will receive the traffic from the private subnet. It will mask the actual private IP addresses, and it will provide some dummy IP addresses, and request will be forwarded to internet gateway for the anything. Yeah, it will mask the actual IP address, and then it will forward the request to the internet. So now we are going to create the NAT gateway. For that, left side you can see, right, NAT gateways. Click on NAT gateway, create NAT gateway. So I'll choose it as regional only. First we need to name our NAT gateway. I'll name it as Eduwise NAT gateway. Eduwise NAT is enough. Yeah, for which VPC we are going to create this NAT gateway, we need to choose this VPC as well. In our case, our VPC is Eduwise VPC, and connectivity type will be public only. Yeah, proceed with creating the NAT gateway. Yes, right now we have created NAT gateway as well. Now we left with route tables. So for that, at left dashboard, you can see the route tables, right? Click on this route tables, click on this create route table button. We need to name the route table. So I will name it as, guys, just give me 1 second. Okay, here we need to name our route table. I'll name it as Eduwise public route table. You can name it whatever you want. For the understanding purpose, I'm giving names like this. So for which VPC we are going to create this public route table. So here you can see, right? So from internet gateway to this public subnet, right now we are creating route table from internet gateway to public subnet. So because of that, I have named it as public route table. Once route table is attached from internet gateway to this public subnet, the resources, I mean EC2 servers which we are going to create inside this public subnet will get a direct internet access. So because of that only, this subnet become public subnet, right? So now we will create the route table. We are going to choose the VPC, create route table. So now we have created the route table and we need to route the traffic, right? So for that, we need to choose this routes option and click on this edit routes. Here we need to add the route for the internet. Uh, we should directly access the internet, right? For that, we will choose 0.000 and target. See, if you observe carefully, this route will be attached to target internet gateway IGW from public subnet to internet gateway, right? So for that, here we will choose internet gateway. And again, in this internet gateway, we need to choose our IGW. See, this IGW we have created for our VPC, right? So we need to choose the exactly the IGW which we have created for the VPC. So I'm going to choose this Eduwise IGW and save the changes. Yes, we have configured this route table to access the internet. Again, right now we have configured route table to access the internet like 0.0.0/0 to this internet gateway. But still this route table is not associated to the public subnet. So in the next step, we are going to associate this route table to the public subnet. We have configured this route table to access the internet gateway, but still this route table is not associated with this public subnet, right? In this step, we are going to associate with it. So for that, again, here you need to choose subnet associations and then click on this edit subnet associations. Here we will get two subnets, right? So right now we have configured this particular route table with the internet gateway. So because of that, I will choose public subnet. Now we are going to save this associations. Till this step, before associating this route table to the public subnet, this subnet is actually private subnet only because it doesn't have internet connection. Just now we have associated this route table from internet gateway to this subnet, right? So after that only this particular subnet became public subnet, meaning now this subnet has direct internet access. In the next step, we are going to create the one more route table and this route table will be associated from this private subnet to NAT gateway. Again, click on this route tables, create route table, provide route table name, private route table name, Eduwise private route table and choose the VPC and create route table. See, right now we have just created the route table. Again, we need to edit the routes. For that, edit, click on edit routes, add rule to the internet. So this route table will be routed traffic to the NAT gateway, right? So for that, here we will choose NAT gateway. NAT gateway and again we choose the NAT gateway which we have created. Yeah, I'm going to save this changes. Again, we need to edit this subnet associations as well. Yeah, now we have created one route table. This routed to the NAT gateway, but still this route table is not associated with this private subnet. In this next step, we are going to associate this particular route table with the private subnet. So click on subnet associations, edit subnet associations. Here we are going to choose the private subnet. Save associations. Yes, right now our complete VPC setup is done. I'll show you the this resource map as well. Eduwise VPC is our VPC, and see, we have created Eduwise VPC. Inside VPC, we have created two subnets. Eduwise public subnet and Eduwise private subnet. For these subnets as well, we have created two route tables. So one is from, see, this is internet gateway. I'll enable this all details button as well. So Eduwise IGW, internet gateway. For this gateway, these two are default route tables. No need to worry about these two. We can disassociate these two route tables. So from our end, we have created Eduwise public route table. Yes, that thing you can see here. And for the private subnet, we have created a NAT gateway, and traffic will route through using this Eduwise private route table. You can see, right? So for the moment, you can ignore these two route tables. No need to worry about. By default, AWS has created these two route tables. No need to worry about these two. So from our end, we have created one VPC with CIDR range of 10.00/16. Inside this VPC, we have created two subnets, Eduwise public subnet and private subnet. For these two subnets, we have created two route tables, Eduwise public route table and private route table. From the public route table, traffic will be routed from public subnet to internet gateway. And from private subnet, traffic will be routed from using Eduwise private route table. We have configured to route the traffic from private subnet to NAT gateway. NAT gateway will mask the actual private IP address and it will forward the request to internet gateway. That's exactly how we are going to create the AWS VPC.